Okay, so right here is my Twitter handle @BrownGirlDev, where you can find the slides and resources for this talk. So you don't have to worry about missing anything because you'll be able to get it already out there online. Now, when we hear the phrase "first do no harm," we often associate that with the Hippocratic Oath, which is essentially a set of ethical standards that doctors swear by with the purpose of ensuring that they provide high quality to all of their patients. In fact, it takes a lot of work to become a doctor. So I sat down with a doctor friend of mine, and this is more or less what he said was required. So as you can see, they're majoring in math and science, endless exams, rotations, residencies, internships. Why do you think we require so much of our doctors? Isn't it because we trust them with our lives and the lives of our friends and family? Now, as software developers, we have the power to connect people with the information that they need the most. They use it while they're on the go, perhaps while they're working, in order to accomplish their day-to-day lives. However, unlike doctors, we weren't required to take any particular type of oath or pledge to become an Android developer. At least I wasn't. Okay, yeah, you either, right? But we can still learn a lot behind that phrase, "first do no harm." One thing people ask me a lot is, "Annyce, how can I become an Android developer?" I'm hoping that today I can not only answer this question, but this one as well. How can I become a great Android developer? What is it that you can do in order to distinguish yourself in the community and really constantly deliver high quality products? Now, the first thing we're going to talk about is the way that we approach study. Now, as we saw, doctors go through a long 7 to 9 year process before they're officially doctors. However, they don't just stop learning at that point. They don't just close up books, "I know everything about medicine." They go to conferences, they read medical journals, all in an effort to stay up to date. Likewise, as Android developers, we have a ton of things that we can avail ourselves of in order to stay up to date in our field. So I just want to share some things that I've personally found invaluable in helping me to keep up with the changing pace of Android development. And so the first is newsletters. Now these are my favorite ones: Kotlin Weekly, Android Weekly, and Android Dev Digest. I love them because they're vetted. Now, I'm a big fan of Twitter, if you know me at all. However, there are tons of terrible links on Twitter, I'm just gonna be honest. But when I look at a newsletter, I know that there's a team of people who've already vetted this information, so I can click through the articles with confidence, and I typically learn something new every single week. The next thing I wanna mention is podcasts. So these are all of my favorite podcasts that I love listening to. And it's great because I tend to be on the go. So either I'm going to do laundry, I'm going to fold clothes, I'm going, there's a theme here, right? So there's all these things I have to do. And I can listen to a podcast and pick up 1 or 2 things that, oh, that sounds interesting, I'm gonna investigate that later. Android developers backstage in particular, I wanna call out, they have a lot of interviews with people who work on the Android framework. So instead of just like reading a blog post and kind of finding out how something works, you find out why it works in that certain way, what was their motivation for developing it that way, and you can have a deeper understanding of the technologies that we have to interact with. The next thing I want to call out are online courses. Now, these are great because you can learn at your own pace, so no one's pushing you to do it in a certain amount of time. They cover all aspects of Android development. So you can learn about layout files, publishing things on Google Play, perhaps developing your own SDK. You can learn all of these things online. Also, there are different perspectives. So depending on the course's author or the company, they can both be talking about how to develop applications with MVP, but they each do it in a completely different way. And so you can learn something and customize it to the way that you prefer to work. Now here are a few from Udacity. I've taken all of these. And what's really cool about this is you'll notice that some of them are for beginners and some of them are for advanced developers. But I was able to learn something in every single one of the courses. So this is really nice because if you come to something with like a sense of humility that, hey, I don't know it all, I have a few things left to learn, you can still pick something out when you decide to tackle an online course. The next thing I want to shout out is Caster.io. Full disclosure, I'm one of the instructors. But what's cool is that these people actually make Android apps day to day. So you get a real world perspective of what's going on and how to use the updated libraries. And I actually watch the courses of my fellow instructors, and I'm learning something new all the time. I found this quote, and this will be the official quote of the day, I guess I'll say. And what I really love about it is that if you decide to associate with people who are flying high, so to speak, then you can similarly achieve that type of level. And what is an amazing way to associate yourself with people who are doing cool things in the field? Conferences, right? Just like where we are today. So if you look to your left and you look to your right, you see people who are super passionate about Android. Either they're trying to learn, they want to expand, they want to tackle new techniques right here among you. Also, what's nice is you get to hear from the experts. So if you're just getting started, maybe learning ArcJava, there's going to be someone here who's an ArcJava expert already. You want to know about Kotlin. I've already seen at least 3 to 5 Kotlin experts here at this exact conference. So this is your chance to connect with them and grow your network. Let's say you want to know more about IoT. Well, you're not doing anything right now, but there may be someone here who's an IoT expert. Get them in your network, and then a year from now, 2 years from now, you can tap into that person. You can also learn new techniques. So let's say you're here, you always do things Y. Then someone's like, hey, here's Z. You're like, oh, wow, that's amazing. I didn't know Z existed. Like, from now on, I'm always going to do Z. All because you had the opportunity to attend a conference. The next thing I want to talk about is open source. So open source is awesome because you get so many examples of how to do something, and you can just look at it for free. It's just out there. You can learn by doing. So if you have a schedule which allows you to contribute to open source, you can then contribute and get feedback from people who are experts in the industry. Also, you can see design patterns in action. One thing I love to do is if I'm incorporating a library inside of my applications, then I'll look at the source code and I'll try to pick out different design patterns that I see. So, oh, look at this, they're configuring something, this is the builder pattern. That's a great use case for that. And I'll just go through their code to see how they're doing things and what I can learn from it. So, starring. This is GitHub, obviously. GitHub, love it. I star everything. Like, I just star anything I think I might need down the road. I'm like, oh, cool, weather and forecast for humans. Starring it says Android. I don't have a way to filter yet. So GitHub, if you're listening, I'd love that ability. What's nice, you can also follow people on GitHub. So you can see like which libraries they're working on, things that they've found that are interesting, just kind of keeping up with new things almost as soon as it hits the internet, which is awesome. So we've looked at everything under study: newsletters, podcasts, online courses, conferences, open source. And what's great is almost all of these things are free. So people in the Android community are willing to share their expertise with us for free, and we just have to put in the effort to avail ourselves of it. So let's go to our second section, and that is prevention. So in the medical profession, they vaccinate people in general, right? They believe that vaccines are there to try and prevent diseases. Okay, so what can we do as Android developers to prevent bugs making their way into our application? So I'm gonna go through these 4 areas: static code analysis, code reviews, leak canary, and then testing. So when it comes to static code analysis, in Java, the checkers kind of work in 1 or 2 ways. They're looking at source code or they're looking at bytecode. But there tends to be a lot of overlap among the various checkers. So we have like lint, check style, find bugs, PMD. They all have their own unique ways of finding bugs in your application, but then there tends to be a nice little overlap. So when I was preparing this talk, I sent out a survey to like 200 some Android developers and just said, hey, what tools do you use in your day-to-day work? And here are the answers on the static code analysis questions. So as you can see, like most people are using lint, and then, you know, not so much these other things, but check style and find bugs popped up a lot, which is pretty cool. So most people are familiar with check style. It's more so focused on like formatting, cyclomatic complexity, things like that. But find bugs is often overlooked. So I figured I'd just show you briefly what find bugs can do for you. So first, it's looking through your code to find patterns of bad usages. And then it kind of just gives you this statistical analysis of the warnings and issues that it found in your code. When you dig in deeper, it'll try to explain why that particular thing you've done is not best. So for example, you had a field, it wasn't final, so someone could, you know, hijack it. Or you have a class and it's not a static inner class. So all of these things can help you. It's just sort of like this neutral third party looking over your shoulder at your code to try to make it better. So now I want you to imagine you're going in for a medical operation, and you go in the room, you're already nervous, and this is what's waiting for you. This lone doctor, ready to perform this complex procedure. Wouldn't your anxiety kind of go up even more when you saw this? Now, imagine yourself in the same room, but instead you have this, a team of doctors. So you have someone monitoring your vitals. You have someone else making sure the proper procedures are being followed. Someone else making sure they're using the right tools, all in an effort to make sure things go smoothly for your operation. You still will be nervous, but you'll feel a lot better than you did in the previous scenario. And that is the same thing we get when it comes to code reviews, right? So this is so important to have code reviews in our organization because we're working as a team to make the code better. So first of all, code reviews help you catch issues before they get to production. So you can have people on your team looking over things, waiting to find the issues, right? It also helps to keep the design consistent throughout the entire application. So multiple eyes are on the code, things can be consistent. And then we can make sure best practices are being followed the entire time. So this is just some of the few benefits that I want to highlight about having code reviews in your organization. Now, I don't work at GitHub, but I do appreciate the many features they give to us developers. And one of them was the code review improvements they added a few months ago, where you can actually choose people that you want to review your code. So we love to take advantage of this at my company, and we'll choose people who we feel are in the best position to comment and give feedback on changes. And then we can have this nice conversation back and forth about what we want to see enhanced in the code. So super useful. Okay, now this brings us to Leak Canary. And I grappled a little bit about including this one here because it's preventative and diagnostic, but we can really focus on the preventative nature in this section. Now the setup is pretty much this. It's like really simple. Just add these things as dependencies, minor modifications in your application class, and you can start taking advantage of what Leak Canary can offer. So let's look at an example. If you were presented with this code, what would you say is wrong? Question to the audience. Just what do you think? Just by looking at it. Right, over here, static toolbar, right? Someone said that, great, amazing, yes, that's the answer. Okay, so you don't even need Leak Canary, right? So static toolbar, this can cause leaks in your application. Now, if you have Leak Canary, what's nice is you'll get a notification saying, hey, this activity leaked. And then you can click into it, and it'll actually go down and kind of point out there's that toolbar. So just like that, no, we're not all magicians like this person here, where we can just look at code and immediately see potential leaks. But if we have something like Leak Canary, we can take advantage of it, which is really cool. So let's move on to architecture, right? The way we structure our applications can have a huge impact on our ability to prevent bugs from getting in the first place. So let's look at this example of foo. So we have foo. It's this huge God class, tons of dependencies. It's easy to get bugs into foo. It's harder to maintain it. If we want to add something else, it's more likely that we're going to add bugs. Instead, it's better to break up foo's dependencies and spread the love out among multiple classes so that your code is easier to maintain and modify in the future. Now, how do I like to do this? Currently, I love the combination of Model View Presenter, or MVP, with Dagger. It works really, really well to kind of keep my code modular, and we have tons of unit tests because we've separated out our application in this way. Just one final example so you can kind of see how it works. So let's say we have like activities and fragments, presenters, some service, has conversations with repository and database, and then we use an asynchronous mechanism to kind of give it all back, either event bus or RxJava. So just like this, we can have a very nice decoupled application that is easier to maintain and lets fewer bugs in. So let's move on to testing, and specifically API testing. So I don't know if you've been in this situation before where something in your Android app breaks. You go to the API team, they're like, no, that was always a float. No, actually, that wasn't it. Well, it's a float, you have no proof. But my code isn't it. I don't know how your code used to work, it's not our fault. And the finger pointing continues endlessly. So I had enough. I was like, okay, no, it was an int. From now on, I'm gonna have proof, and enters Postman. So this is a perfect tool for testing your APIs. That's easy for someone who's just an Android developer who's not as familiar with backend to create tests and ensure consistency. So let's look at how it works. You have Postman, you send a request, you get back a response, and it runs the test scripts. It's really just 1, 2, 3, boom, boom, boom. Let's look at an example. So I'm here inside the Postman GUI on a Mac, and I have a list of requests that I've already executed in the past, and now I want to run them and get a response. So what you'll notice is over on the left-hand side is the list of requests. Then in the center, we'll see there's a get URL that I want to execute, and then there's this giant blue button that says send. Just click it, and then there's my response that shows up on the bottom. So it's really simple, all you have to do to use Postman. Now, here's a close-up of that response. So let's say this is your real-world response that you need to integrate inside of your application. Let's look at how we can write some tests for it. So first, most basic test ever is making sure the request was successful. So you just write this one line of JavaScript code, and every time you make that same request, it will run this test and let you know whether or not it was successful. It's JavaScript, but it's extremely benign JavaScript that I can stomach. So yes, this is great. We've already well on our way of verifying our API. Now let's go a step further. We realized that that was an array that we have received in our response. Now we want to make sure we are always getting an array or null. So we can start to create this schema to say, hey, I need an array or null. I'm going to parse it, and then I'll use this validator to make sure those things map up. And just like that, when we run our requests, first it'll check to make sure it was successful, and then it will check to make sure we received an array or null. So we're once again getting one step closer to making sure our API that we receive in our app is valid. But it gets even better than this. Let's say we want to be able to verify every single piece of the JSON that we receive back. If you take a look, here's our schema. So we have like some integers and we have strings. And we want to make sure these things are always valid. Here's the schema that we can create. I just kind of want to focus more so on this section. You can specify the properties of every single piece of your JSON, just like this in this sort of hash map format of JavaScript, and say, look, the user ID has to be an integer. The ID has to be an integer. This has to be a string. And now you have something that Postman can understand in order to validate the JSON. So when you do run it, it will tell you exactly which piece is invalid. So you'll never have to worry about, wait, I thought that was a float or I thought that was an int, because you can even store all of the responses that you receive from the API and tag them with a date, which is like one of my favorite things to do. Every now and then, I just tag it with a date so that I can go back in history and just tell them, like, no, June 3rd, here you go. Here's the response that the API sent me. So we have proof, like no more games with the API. And you can set up monitors with Postman. So it's like a premium feature, I guess, that they have available. But you can have all your tests run against your API at a certain time. You can get an email report from it. You can send it to the entire team, and it'll go through running all of the tests. So this is really cool. We've even connected ours to CI. So just like once a day, we hit the staging server. We run all the tests we have set up in Postman, and then it's like pass-fail. So it's really cool. So when it comes to prevention, we looked at 4 areas. So static code analysis, code reviews, leak canary, and testing. And I kind of just scratched the surface on most of these. So I would encourage you to take the time and look deeper. There's so many other ways to check your code for validation. If you're using Kotlin, there's new tools out there in order to verify your Kotlin code and syntax. So try to take advantage of those things. So let's look at our final aspect, and that's diagnosis. Now, when a doctor is presented with different symptoms from his or her patient, they have to do some work. It's not an automatic, okay, this is the issue, right? They have to look at the person's history. They may have to do a physical exam. They may have to use various procedures and tests to find out what the main issue is. For example, let's say a 74-year-old comes into a doctor and goes, I have a lot of stomach pain. Okay? A 34-year-old comes in, I have a lot of stomach pain. Do you think that they both would get the same exact diagnosis? Who knows? Probably not, right? Like maybe one is running marathons, perhaps the other one isn't. We don't know. Like there's so many different scenarios. And so a doctor will look at that person's history, their age, race, all these different factors that could contribute to their diagnosis. And so likewise, when it comes to finding bugs and issues in our Android applications, the key factor, the best tool in figuring out what the issue is, it's you, right? You wrote the code. So you know the scary places that you don't ever want to modify. When someone says like, hey, we need to update this, you know that look on your face. So you are the best tool in order to debug issues and really get to the root. However, just like any good doctor, you need to use tools. Every doctor doesn't just go on their gut, right? They have tools available. And so we can do the same thing. So at this time, I just want to give you 30 seconds. Just think of the top of your head, your 3 tools that you use all the time for debugging issues. Just really quickly, like right now, you should have already thought of 3 at least. 3 tools you use for debugging whenever you have something wrong in your app. Eight, 7, 6, 5, 4. All right, cool. Now, just spend like a minute telling the people at your table what 3 things you picked and why. Just like really quickly, what 3 things did you pick and why? Okay, one more minute. Oops. How am I on time? Okay. Okay, awesome. So let's share. Maybe we can, I just would like to have maybe 2 or 3 brave people who are willing to share some of the tools that their table discussed. So anybody, just what are 3 things that your table discussed? You don't have to explain it, just say it. I know you've had coffee. Come on. 1, all right, yes.
We talked about debugger, log, and layout.
Cool, thank you. Very nice. One more table. Want to share your 3 things that you discussed? All right, yes.
Same, the log path, debugger, we also talked about check, set the new network analyzer tools in Android Studio.
Cool, awesome. So we're actually going to talk about a few of those things, so it works out really well. Now, Android Studio is our IDE of choice, and it's probably the best tool we have at our disposal right now to debug issues inside of our Android apps. But we're going to get to that later. We'll first focus on things we can do in our own code, things we can do outside of Android Studio, inside, and then we'll look at on our device or emulator. So let's start with our own code. What's the most basic thing we can do to debug issues? Write logs, right? So we kind of talked about this a little bit, this one table using logs. In this example, post in a log if an error happens. I like to use Timber for this. It's the perfect library because you can filter out which things make it into various builds, production, release, staging, etc. And then you can take advantage of logcat, or this, in this example, this is pidcat, because I don't know why logcat doesn't work for me sometimes, just stops working. So I just go to the terminal and I use pidcat, and I can see what's taking place and track down these like really simple issues in my app, right? But what about when our users are out there in the wild? First of all, we don't even know who they are. We don't know what they're doing with the app. So how can we try to debug and figure out what's taking place whenever they encounter issues? Well, that's why we would log events. Right, so here's an example. Most people have some type of analytics inside of their Android apps. You can just throw on Crashlytics, and whenever you track something, you can just send a log to Crashlytics as well. Now, what is something like this buy you? If we take a look, when there's a crash that happens inside of your application, Crashlytics will also attach logs to that crash. So it's just kind of like little breadcrumbs where you can figure out what the user was doing before the crash happened. So in this example, they had failed to log in. Somehow we didn't handle that successfully, and the app crashed. So imagine if there's like really long, drawn out wizard flows or whatever inside your application. You really don't know like what step in the flow did they fall off? What step in the flow caused this exception to happen? By adding that little bit of code inside of your application, you can definitely follow them and track it down. Now that brings us to things outside of Android Studio. And for that, Crashlytics. So we talked about this a little bit, but it's extremely powerful. One thing that's really nice about it is that they can group your releases for you. You can look and say, okay, 2.12 was a successful release. You can look at previous releases and see if they were successful or not. And you can really hone in and make sure you're keeping your application stable almost as soon as you start the rollout. So this is nice if you're using Google Play stage rollouts, since I really recommend that. Once you start your rollout, you can monitor this tab on Crashlytics, and then you can see like, oh, okay, are we okay with this release? Can I increase the percentage? So it's a great way to be ahead of the game when there's issues in your application. You can also find out like which devices and operating system your users are on. So our application is mostly used in Africa, and there is a phone called the Techno that clearly like mostly everyone is using. And I didn't have a Techno. I mean, I'm testing on like my Pixel, but is that really being, you know, an advocate for my users? No, right? So I said, hey, I need a Techno, and now I have a Techno on my desk, testing on it all the time. In fact, I'm testing on it on KitKat because that's what a lot of our users have, and that's helping me to be in a better position to debug issues when they do arise. The next tool I want to talk about is Classy Shark. And I like it more than just its name because it's Classy Shark. I like that name also. But if you've ever struggled with a bug that wasn't part of your source code, Classy Shark is perfect for that. And it gives you this very nice visual view of the various packages that the third-party libraries are bringing into your app. So I especially like to look at this to just get a quick view of like what's happening with these other libraries that I'm incorporating. It also has this really cool APK dashboard. So you can just look at this one and see this section, possible Java dependencies error. So you can look there really quickly and see if your third-party libraries are bringing in other weird libraries. So often there's like this graph. They're all going to depend on something else. So you don't know, they might be bringing in something that should only be used on a server and not inside of your Android app. So Classy Shark is a great way to check that. The next tool is Battery Historian. So this, as the name implies, lets you inspect battery-related information about your Android app. And I really like this one when I get complaints about the app on like draining their battery. They don't have a lot of information. It's like, the app drains my battery. Okay, so this is when I break out Battery Historian, and I can kind of use this to gauge what's taking place. So if we take a closer look just at this one particular trace, you'll see there was one occurrence of the GPS, and then if you look, the active duration, 26 minutes. That will certainly drain someone's battery, right? If the GPS just stays on all that whole time, and that wasn't the intent. So I'm like, oh, sorry, everybody. Let's fix this issue. And then instead of having this long red line of GPS, it went back to just like bloop, bloop, bloop. That's how it's supposed to be. So Battery Historian is amazing at helping you catch these kind of issues where you can see an actual line of how the battery drain is taking place. Another neat thing about it is that it can rank the different apps on the device by CPU usage, so you can see which app is causing trouble more or less. So in this example, I thought it was really interesting that Fitbit was like among the top 5 apps that like use CPU on my phone since I barely walk. So I was just like, really Fitbit? Like, what are you doing? But I found that out from Battery Historian. So if your app is in the list, you know, you might have an issue. Like it probably shouldn't be in this list of using up all the CPU on a particular device. In fact, if you want to know more about it, this section in the Android developer documentation is amazing. It just goes through everything about the battery, what you can do to improve it, things you can do to diagnose issues, how you can optimize it. It's perfect. So our final tool outside of Android Studio is Systrace. And I saved it for last because I hate it, but I love it. It's weird. But Systrace, it gives you tons of information about what's taking place. It's just not the best thing to look at, but it works really well. And if you don't want to dig into all of this, you can just look at the colored circles. So green is good, and then yellow or red is not so good. Maybe you need to investigate. And if they keep being like spread farther and farther apart, okay, you may potentially have issues. So really quick visual inspection of Systrace, that can get you somewhere. Even easier, they have this alerts pane. You just click it, and it'll give you a list of all your issues. Click on one of those, and it tells you exactly what's taking place. And in the latest version of Systrace, it gives you a video. So like, just watch this and fix your problem, right? So it's really cool about Systrace. So let's look at inside Android Studio. First is APK Analyzer, which is just really nice because like back in the day, you really didn't know what was going on in your APK. You could try to like unzip it and figure some stuff out. Now you get this really nice visual tool to inspect what's happening inside of the APK. And I like this a lot when I get issues from QA about the pro-guarded version of our app. So I can just kind of dump that APK in here and see what's taking place. So it's really useful for things like that. Next is the Android Profiler. So this replaces the Android Monitor tab in Android Studio 2. Whatever. And now it's 3.0. So we're all going to be using the Profiler. And just really quickly, I want to show you kind of the different things we can take advantage of. So this is just using the memory profiler. Here you can look at like garbage collection, take a heap dump, figure out what's taking place. And this used to be spread out among multiple tools, but now it's all in one place. So that's really, really neat. Next is the CPU profiler. Same thing, you can look for spikes in your CPU. You can get information about the various threads that have been executed. And then you can even like hone in on a certain amount of time in your app in order to do that particular type of investigation, which means that you no longer need to use trace view. Kind of sad, but hey, we gotta move on. Times keep a-changing. Next. Network. Okay, so if you're using like OKHTTP, which many applications are, you can now take advantage of this to profile your network, and you wouldn't have to use like some like man-in-the-middle proxies or like people use Charles proxy and things like that. If you just want to kind of look at what's happening with the network, you can now do that inside of Android Studio, which is pretty cool. You can even kind of click through and see the actual response that came back in any images that came through, which is really awesome. So let's look at the emulator, and we're gonna kind of go through this one really quickly. We're almost done. One option is GPU overdraw. So this was talked about a little bit in one of the talks yesterday, just to kind of help you see if you're getting lag inside of your app. So this is one of my favorite apps, Pocket Cast. And you see they do actually a really good job with their UI. They don't have a bunch of light red and dark red, which means tons of overdraw, which could potentially slow down the screen. Another option is profile GPU rendering. I use this one when certain devices take a long time. So not every single device has an issue, but they may say the Techno W5 is having an issue. I turn this on to try to figure out, well, what is it about this particular device that's causing the issue? And then I'm trying to keep things under that green line for the 16 milliseconds. And then here's a great chart from the developer documentation that explains all those various colors. Now, we have looked at over a dozen tools, believe it or not, that can help us in either preventing bugs in our apps, diagnosing the cause of them, and just having high quality code in general. So I hope that maybe you learned about at least one new thing today. So you've made it to the end. You can give yourself a pat on the back. And I know we kind of covered a lot and I had to move quickly. And things in this industry are constantly changing, so by the time I will give this talk 2 years from now, there'll probably be a dozen new tools that you can use to improve your application. But the key thing that I'd love for you to remember is that it really takes effort to study, to keep yourself like really aware of what's taking place in our industry. You have to use preventative techniques to keep things from even getting in your app in the first place. And you have to skillfully know when and where to use what particular diagnostic tool to really be a great Android developer. But regardless of which thing you decide, I am going to tackle this next. First, do no harm. I hope you saw that coming. That's the end. Thank you. Okay. All of the resources that I talked about today are listed on my website, so you can find that link pinned to my Twitter. There we go. Why can't you guys be like the people next door? Thank you. Yeah, so I'll be around for the rest of the conference if you have thoughts, questions, or concerns.